Myself, Kedan M. Patel from Mahatma Gandhi Institute of Technical Education and Research Center, NAVSARI, Electrical Engineering Department. My subject is freeze, year and protection. 4th year, 7th semester. Chapter number 3, Differential Protection. Okay, syllabus content. First is simple differential protection. Second is percentage differential protection. Third one is zone of protection of differential relay. Next, voltage balance differential relay. Next, circulating current protection for bus bar, earth leakage protection for single phase load, and earth leakage protection for three phase load. Okay. Now, first is simple differential protection. Okay. So, what is simple differential protection, or what is differential relay? A differential relay can be defined as a relay that operates when the phasor difference of two or more similar electrical quantities exceeds a predetermined value. Okay. The differential relaying is the most selective relaying principle that detects faults by comparing the electrical quantities at all of the terminals of system element. Most differential relay are of the current differential type relay. Here this is a simple differential protections figure. Now here two identical current transformer like a CT1 and CT2 are connected on the both two sides. The polarities of these are kept such that they carry current in the same directions. So this way, okay. Here this is external fault. Okay. So same directions of CT1 and CT2. Suppose these currents are capital I1 and I2. Okay. When there is no fault, value of current I1 and I2 will be equal. So there will not be any potential difference across the point this A and B line. Okay. So no current will flow through the relay coil connected across these points, and relay remain inoperative. Okay. So this differential relay will not operate because of the external fault. Okay. But now the internal fault is occur, okay, like this. Okay. CT1, CT2, between this any protective equipment like here this is generator winding to be protected. So here the internal fault is occur. If fault occur, the current balance is disturbed. So the current I1 and I2 will be different. So current I1 plus I2 will flow through the relay coil. Such a current is responsible to operate the relay. Okay. In CT1, I1 current is flow from this way and I2 current flow by CT2 this way. So this is a relay, like a differential relay. So I1 plus I2, and again this relay will flow I1 and this way I2. Okay. So circulate the relay coil. Okay. So this is a simple differential protection, but it is not important for protection purpose. It is some disadvantages. This basic differential scheme has following disadvantages. First is these circuits operate inaccurately with heavy external fault. The CTs may saturate and cause unequal secondary currents, and the different secondary currents may approach the peak of value to operate the relay unnecessarily. So these disadvantages are overcome in the percentage differential relay. Next, percentage differential protection, or we can say percentage differential protection scheme. Okay. This is the basic percentage differential protection scheme for generator winding, like the generator. It is also called bias differential protection scheme. This is the protected winding, like a generator, motor, or any other equipment. Here CT1 and CT2. This is a percentage differential relay. In this coil name is operating coil. And this coil name is restraining coil. Okay. So percentage differential relay has two coil, operating coil and restraining coil. Okay. When fault occur in alternator or generator windings itself, the current balance does not remain and the relay operates. Now when the alternator supplies the fault current to the external fault, current on the two sides become equal. But if the saturation characteristics of the two CTs are not identical, there is a difference in the secondary currents of CT, even when the primary currents are equal. This means I1 is not equal to I2 and current flow through the relay. Now this is not the fault current of the alternator and the relay should not break. To overcome this difficulty, by percentage differential relay or bias differential is used. In the bias differential relay, there is one additional coil which is known as restraining coil. The coil is in two sections. One lead of the operating coil is connected to the center of the restraining coil and another end of the operating coil is connected to the pilot wire. Okay. So this is the operating coil is connected to center of the restraining coil. Okay, so this is N1 turns and this is N2 turns. Okay, or we can say NR by 2 and NR by 2. Okay. So total number of ampere turns of the restraining coil are I1. Okay, here is the I1 current and N by 2 NR by 2 plus I2 into NR by 2. So where N is the total numbers of turns of the restraining coil. Okay. So the average restraining current through the N turns becomes I1 plus I2 by 2. Okay. Here this is also other figure of percentage differential relay. This is the core and this restraining coil. In between midpoint, the operating coil is connected into this point. Okay, so N by 2 and N by 2 turns. This is operating coil, this is restraining coil. Okay, and this is the strip circuits contacts. Okay, this is CT1 and CT2, and in between CT1 and CT2, the protective system element is connected. Okay, so when the winding fades, the external fault value of both I1 and I2 increase, the value of the differential current increases. But at the same time, the value of the restraining current also increases. So the relay cannot break. Thus, malfunctioning of the relay can be prevented. Okay, so relay is the average restraining current increase with the increase in the differential. In this relay, the ratio of the differential operating current and the average restraining current is a fixed percentage. So this relay is also called the percentage differential relay. Okay. So this theory is very important in protection purpose. Okay. So this is a percentage differential relay, or we can say bias differential protection. Okay. Next, zone of protection of differential relay. It is a simple example of zone of protection of differential relay. Consider that the fault located at the point X. Okay, like this external fault and this external fault F external and this is the internal fault F int F. When the fault is outside of the zone protection, okay, outside means this external fault, it is known as external fault, and inside fault is known as internal fault. If the two current transformers have the same ratio, like 10 by 5, 20 by 5, and properly connected. The secondary currents are of some magnitude and phases. The difference current therefore being 0. So no current will flow through the differential relay. Hence, relay does not operate. If fault develops in the protected zone, it is known as the internal fault. The differential relay will operate. When the internal fault develops outside the protected zone, relay will not operate. Okay. So this is the zone of differential protection. Okay. Outside fault or inside fault. We can say external fault or internal fault. Okay. Here this is the equipment to be protected, like a transformer winding. Next, voltage balance differential relay. In the voltage balance differential relay, the current transformer at the two ends are connected in oppositions, okay, directions. The relay are connected in series with the help of the pilot wires. The relative polarity of the cities is such that there is no current through the relay under balance or through fault conditions. Okay, here this is city 1 and city 2, both direction is opposite. Okay, so this city is connected with the relay 1 and this connected with CT2, and again relay 2 to CT1. This is the protected system element, a motor, wind, or generator, or transformer, etc. Okay. So the requirement of the CT is that they should induce voltage in the secondary linearly with respect to current. The magnitude of the fault current is very large in order that the voltage should be linear function of such large current, and the CT should be air-cooled. Okay. Differential relay are ideally suited for protection of compact items of electrical equipment such as generators, bus bars, transformers, reactors, motors, and short transmission line. So it's also used in different applications, like various applications of differential protection are listed. Like first, this type of protection scheme can be used for protection of generators, transformer, generator transfer unit, and transmission line. By using pilot wire, differential protection of transmission line can be done. Burst zone protections, protection of large motors, protection of transmission line, by phase comparison, carrier current protections, protection against the intermittent fault. Okay. So there is the voltage balance differential relay, large numbers of applications in protection systems. Next theory is circulating current protection for bus bar. The circulation current protection is the protection that responds to the vector difference between two or more similar electrical quantities. This merge bias system of protection can be used for the protections of bus bar also. Here this is circuits. Here this is generating station 2, load. Okay. Here this is circuit breaker protective equipment. Okay. Here this is the bus bar. Again this is a different feeder. This also used in circuit breaker CT. This protection system. This is also protection system. Okay. With connect to the relay. Okay. So power is fed to the bus bars to the generator. There are two outgoing feeders. Okay. One CT is connected to the incoming line and one CT is connected to each outgoing line. Okay. CT. Here is this CT. Secondary winding of CT are connected. Okay. The current in the secondary winding are balanced as the incoming and outgoing currents are equal. Okay. In magnitude in the healthy conditions. So no out of balance current flow through the relay and the relay remains inoperative. Current balance is disturbed when the fault occurs. So the out of balance current flow through the relay coil and it operates. So this is basic and simple theory of circulating current protection for first coil. Okay. Next there is earth leakage protection for single phase load. In earth leakage protections, many times due to the failure of the insulation of the body of an appliances, like in home, electric irons, etc. The applications becomes live. Body of the appliances is generally earth, and a leakage current flow through the metal body of the appliances to the earth in case of insulation failure. If person touches to such appliances, he may also. The small leakage current cannot operate over current relay. Hence, special type of device is used to provide earth leakage protection. It is called earth leakage relay or current balance relay. Okay. So, earth leakage protections or current balance relay protections. Now, first we can say earth leakage protection for single phase load. In figure, the earth protection for single phase load, the system consists of current transformer surrounding live and neutral wires A and B with the same number of neutral turn. Okay. Third coil is C. This is A and B. The system consists of current transformer CT surrounding live and neutral wires A and B with the same number of turns N. Okay. The third coil is C. It's called pickup coil. It is also wound on the core, which is connected to the trip coil of the relay. Windings A and P are connected to terminal L and N. Okay. And the device respectively, the coil A carries current IL while coil B carries current IN. Neutral current. This is the phase currents. Phase current and neutral current. I phase equal to IN plus I. Under normal conditions, the current of the conductor IL, okay, line current, is the same as the current in the neutral current IN. Okay, so IN, hence IL minus IN is 0. Hence two flux produced by IL and IN cancel each other, and net MMF acting on the core is 0. Hence no flux link with sensing coil, and the relay is inoperative. If there is a fault, the fault current IF flow through the earth conductor, which is the leakage current. Thus, the current IL is more than IN by the amount of a fault current IF. Thus, IL means leakage current equal to IN plus IF. The difference current IL minus IN is called residual current, which links with the sensing coil. Okay. The MMF linking with the sensing coil is N into IF. This induces the voltage in the coil producing pickup current. This energizes the relay and trip the circuit breaker and disconnecting the supply from the devices. Okay. So this is the protection circuit of the earth leakage protection for single phase load. Next is earth leakage protection for three-phase load. In previous theories, single phase. This is the RYB or ABC, IA, IB, and IC. This is the winding. This is a pickup coils. This is the core. This flux is produced when the any faulties occur. Three-phase load. So IA, IB plus IC equal to IB. This is the earth chassis. In the earth leakage protection for three-phase load, under normal operating conditions, the phasor sum of the line currents is 0. Like IA plus IB and I is equal to 0. Thus the net flux of the core is 0. Due to this MF linking with the pickup coil C, okay, is 0, the relay is inoperative. The leakage current flow or any fault is occur. It completes path through the ground to the supply neutral. Thus, there is an MF linking with sensing coil proportional to leakage current IF. Thus, voltage gets induced in the pickup coil, which energizes the relay and trip the circuit. Finally, to avoid the maloperations due to the unbalance in supply or load, the neutral is also fed to the core of the current transformer. So, this is the earth leakage protection for 3-phase load. So, earth leakage protection is provided into single phase load as well as 3-phase load for protection. So, this is the all theory is related to using the protections of differential relay protections. Thank you.